Thank you for tuning in to this online lesson. This will be your homework for this week, along with the Matthew Ragon Python tutorials that I have posted on the class website. This is where we left off in class. We have one spinner, one wheel here, and we have a button that controls it, and it creates a random timer and a random speed, and it ramps up and ramps down and then stops. That time this wheel seemed to stop pretty close to the middle, but we haven't actually put in the code that will make it always stop in the same place. And if I spin it again, we'll probably not see there. That would be like halfway in between two numbers, and so we're going to want to add in the code to do a whole number stop. So the first thing we want to do is just duplicate these wheels so that we get 3 of them. Right now we just have the 1, right? And we have our code pretty well done at this point, so I think it's worth it to go ahead and duplicate this. You know, we may end up deleting the wheels and then duplicating them again, but for now let's go ahead and put 3 of them. I'm going to go ahead and rename this null coming out of the spinner to a name for wheel post 1. Wheel post 1, and that's in camel caps with a lowercase and then a capital P. Wheel post 1. That's and then go ahead and on this here we want to, instead of op null 1, I want to change that to op wheel post 1. Why did that not work? Oh, because I spelled it wrong. Wheel post 1, that should make it not mad at me anymore. Okay. Yeah, so now we're ready to copy this stuff. So we can have everything coming from the same button. So select the spinner, the wheel post 1, and the wheel, and copy and paste. And now we have 2 wheels, and paste again. Now we have 3 wheels. And let's take a look at that. I can tell you already we forgot to do something, but I just want to go ahead and show you. So if I hit the open viewer here so that I can see both my editor and my viewer at the same time, I hit this and it looks like there's still only 1 wheel. Why? Well, it's because the wheels are all sitting at the same place. So they're all in this one location. So we need to move these other 2 wheels to make them, to fit them into the other. Man, that's taking forever. That's not going to stop. Stop. Well, anyway, whatever. Let it do it. We'll fix that if it's broken. I don't think it might not. There we go. So we need to move over these wheels, wheels 2 and wheel 3, to fill the other slots. So let's do that. So here in translate, that's where in this geometry component here, that's with the wheel 2 geometry component, this is its current X position. We want to move that over. So I'm going to use the value ladder. Again, to use the value ladder, you click and hold and it pops up. Then you can go up and down to what increment you want. And then left and right on drag will move it and increment it by that amount. So I'm dragging this over using the value ladder until it's centered into that center slot. Okay, and now wheel 3. Same thing, make sure that this is what's I'm on wheel 3. Yep, and I'm using the translate here, and I'm going to use the 0.1 value ladder, which is kind of a rough, and now I'm going to use the 0.01 value ladder to get the fine tuning to get that in the middle of the dial. So now we have 3 wheels. Go ahead and hit the button again, and oh, they're all moving the same way. What could be happening there? Well, first of all, it's this wheel post. Everything's getting driven by wheel post 1 right now, right? So look, this is looking at wheel post 1, this is looking at wheel post 1, and this is looking at wheel post 1. So we want to have these look at wheel post 2 and wheel post 3. So I'm on wheel 2. I want to change what it's looking at to wheel post 2. And now go to wheel post 3 and change that so that it's looking at wheel post 3. There we go. All right, that's looking better. Go ahead and run it. Now, they all seem to stop at the same time. There's an offset because we started them at different places, but look how they all stop at the same time. And they all have the same speed. Look how it went a slow speed. And these two said it's the same slow speed, and then they both stopped. Why could that? What could be causing that? Well, remember when I told you about generating random numbers, how it uses a seed value, right? So when we go inside spinner 1, we're generating our random number here in our chop exec, and we're saying we're defining this timer by tdu.rand abstime.frame, and we're multiplying that by 5 and adding 3. And then we also generate random speed par value 0. That's this here, random speed, and if its parameter value 0, which is this, that value there gets defined by, whoops, go away. There we go. It gets defined by this TDU rand here. Now, this is calling on abstime.frame. This is also calling on abstime.frame. Now, you would think maybe that these might be different numbers, but they're going to be the same seed, and so then it'll give you the same random number because the seed is the same. And the seed is the same because you're generating the seed based on the frame, and then you immediately, the next processor cycle, basically, generate a random number using the frame as the seed, and it's doubtful that the frame would have incremented in between those processor cycles. It's highly unlikely because, yes, there are 60 frames a second if this is running at full performance mode, but there are thousands of processor cycles per second. So you're probably sending the same seed and getting the same random number. So we want to actually make sure that this seed here is different. Let me change this active so I can click on things. So that this seed here is different than this seed. And then also we are in spinner 1, right? And if you ever don't know where I am, just for your information, so now I'm going to go into spinner 2, and if you are like confused about where I am in the patch, just always look up here. I'm in project 1, spinner 2. Project 1, spinner 2, right? That's how you can always tell where I am in the patch. So in spinner 1, we want to make sure that this seed here in this chop exec is different than this seed here, and we also want to make sure in spinner 2 that this one is different than both of these, and then that one is different, and then also in spinner 3 it needs to be different from everything else so that all 3 timers and all 3 random speeds are different. So we can use .frame, we can use abstime frame on this first timer 1 thing, and then on this one we can say frame plus 1, That way, and make sure that's inside of the parentheses, right? This is the parentheses. So that just means it'll take whatever frame and add 1 to it. And you think, well, that's not going to be a random number. That's just going to be the random number plus 1. Well, that's not true because that is the seed. Yes, your seed is one different from the other seed, but that's okay because as long as the seeds are different, you'll end up with a completely random, different random number. And there's no correlation between those two random numbers, even though there's a correlation between the seeds. Okay? So if this is abstime.frame, this is abstime.frame plus 1, then in our spinner 2, we need to do the same thing, but we don't want it to be abstime.frame and abstime.frame plus 1 because that would be the same two random numbers as the previous thing. So in this one, we're going to change both of these, and we're going to make this one abstime.frame plus 2 and abstime.frame plus 3. And then on spinner 3, inside spinner 3, and look up here, this is where I am. This is how you can always tell where I am. Project 1, spinner 3. Abstime.frame. So we had plus 0 and 1, plus 2 and 3, and so this will be plus 4 and 5. Plus 4, whoops, 4 plus 5. Now it should be 3 completely random speeds and 3 completely random timer values. Why isn't that stopping? It just keeps going. All right, hold on. Not sure what made that not stop. Stop this time. Let's go into performance mode and try it. See, 3 different speeds. 3 different stop times. Okay, great. Cool. All right, moving on. Let's adjust the camera view a little bit. So I think it's best to open the viewer here as opposed to going into perform mode so that we can make some edits. So you click this little square up here to open viewer. That's pretty big. Let's just resize this down a little bit so that we have some room to look around. I'm going to back up the camera and move the cam target a little bit, so to kind of give us some room so that we can add graphics later. All right, so let's see. So first of all, let's just move the camera back. I think we're at position 1 right now. Let's go ahead and use the value ladder and just back it up a little bit. Something like that. Let's try 2.2. Let's try there. And then here on cam target now, I'm going to change the Y translate of this cam target and move it down to kind of center this in the screen a little bit. There, I like that. This way we can stick graphics up here or stick graphics right here and we can see pretty well. So currently we got if you have the button here placed, then you should be able to click it and the machine will activate, and it doesn't currently stop in order. We want this wheel to stop first, the second wheel to stop second, and the far right wheel to stop last. Currently, sometimes it does that order, but other times it doesn't, as you can see. right? So this is totally backwards. So we need to fix that. We also need to add a mechanism to make these numbers stop when they're at a whole number instead of being like halfway in between numbers like they are now, right? So let's see how we can do that. First of all, I'll go ahead and review how to do this button. It's pretty simple. You can add a button. And then dive inside the button and get rid of the background and the color information. You don't need them. Then dive out of the button, and now you have an invisible button. But in order to put it where you want it, you're going to want to turn on the borders for it. So you go to Look, and on all these different border drop downs, you set them to border A. Then you have a white outlined button down here, right? So then I open this view like this. I can, under the parameters, change the width and size, something like 100 by 250, and then slide the X and Y over until you get it where you want it, right? The other thing is to add that graphic, and that's simply just adding another geometry component, and inside the geometry component we have a rectangle SOP and attached to a material SOP, and that has the render and display flags set. Then we also have the graphic just dropped in there. It's a movie file in top, and then that is mapped to the color map of a Fong material, and then the material SOP down here points to the Fong material. Okay, so then you can create a graphic of the size that would fit inside the machine and move it into place. I actually did. I'm seeing now I did kind of a sloppy job. I'll fix this, but probably not in this video. Let's see. Okay, so so we need to, the first thing we should do probably is add that whole number stop, and that's going to be inside of these spinner components. So dive inside the first spinner component. First thing here, I have the LFO here, and that's only going from 0 to 1, and then it is sent to a null for some reason, and then sent to a math that ranges it from 0 to 10. That is just a little unnecessary, so I wanted to fix that first thing. So here under your LFO, change the, let's see, here it is, amplitude from 1 to 10. Okay, then it will create automatically a number that goes 0 to 10, and you don't need this extra stuff. So I'm going to get rid of the null, I'm going to get rid of the math. Now I have a LFO that goes from 0 to 10. Let's go ahead and do that in the other two spinners so things stay consistent, and you just have to delete them and the connection stays connected, which is a great thing about Touch Designer. So there's spinner 2, spinner 3. Get rid of the null, get rid of the math. Oh yeah, I think I forgot to set the amplitude in spinner 2. I'll have to go back. Change the amplitude to 10. Spinner 2, let's go back to spinner 2 for a second. Here, the amplitude, this instead of being 1, that should be 10. There we go. Okay, so now let's go back to spinner 1. And remember, if you're ever lost and you don't know where I am, you can always look up here. This tells you where I currently am, okay? All right, so what we need to do is add another chop exec, this time attached to this LFO. And we're going to use the changing values on the LFO to execute a small piece of code that will look at that value and decide whether it's a whole number or not. Now, how can we do this? Well, there's a math operation that makes this possible, and it's called modulus. Let's go ahead and add a chop exec. All right, so we have our chop execute here. And we're going to leave this on value change. So this will run every time a value changes in this LFO. And yeah, like I said, we're going to use modulus to decide whether it's a whole number or not. Now, modulus takes a number, divides it by an integer, and then returns any remainder. So if you took, say your number was 4, and you were looking for the modulus of 5 for that value, then it would return 4, because it would be 0 5s with a remainder of 4. Say that your value was 7, and you're looking for the modulus of 5. What would it return? The answer, of course, would be 2, because you would have 1 5 and a remainder of 2. So it cuts out the whole divisors. After the division is made, it throws away the number of 5s, for example, and just returns the remainder. So what happens is if you set up a modulus correctly, then you will have a looping set of values, and when it goes to 0, you know you're at a whole number, because 5 with the modulus of 5 is 1 5 with a remainder of 0, right? And so we can use, in this case, we don't want to know about multiples of 5. We don't want to know about multiples of 2. We really just want to know multiples of single integers. So that would be modulus of 1. So every whole number, it looks to see if there's any remainder. And if there is, then we don't do anything. But when the remainder gets to 0, that's when we execute some stuff. All right, let me check my notes. Okay, great. So what we're going to do is we first are going to, down here on value change, we're going to add some code. So go ahead and make this viewer active. And let me zoom out. There we go. Make sure you put a tab in. And now I'm going to say, I'm going to define a variable here. I'm just going to call it x for simplicity. And I'm going to say x equals put this in parentheses, op, open parenthesis again, quote, LFO1, I believe, right? Is that what it's called? LFO1, yep. LFO1. And we want channel 0 from that. Channel, what's it called? Chan 1. Chan 1. Or you could put just a 0 there. That would work too. You could just put here 0. But that's a little, and that would work just as well. Whoops. If you put in the label, it makes it a little bit easier to understand what's going on. And that's a perfectly okay way to call that value. And then we need to finish this, so we're saying op, we're taking this value, and we're taking the modulus of 1. I don't even think we need those parentheses. I'm just going to leave them on though for now. Okay. Let's just go ahead and print that really quick. Print x. Now go ahead and dive out of the spinner. Open your text tab by saying Alt-T. This will bring up your text port. And now if we activate this button, you can see it creating these numbers. And these numbers are going to be going from 0 to 0.9 or so. See, it prints the same number over a couple times, but that's because it's doing it, it's rounding in a weird way. But you can see that this number goes from something low, something high, down to something low, and then starts counting up. So 0.1, 0.1, 0.4, 0.4, 0.6, 0.9, and then it rolls back over to 0.2. It's a little concerning that it's going that far, but all right, let's take a look. I should be seeing a little bit more values. All right, let's see. That was my stomach. All right. So what we need to do now is, if x is equal to 0, then we're going to stop the wheel. Okay, so the wheel right now is driven by a couple different methods. Let's take a look. The wheel here is driven by this LFO, I believe, right? LFO1, yes. Whoops, let's close this. Go away. Okay, LFO1. Now, this currently is driven by trigger 1. Where's trigger 1? There it is. So this is trigger 1. Trigger 1 creates the tail off, remember? It creates that ease in, this ease in and ease out that we're going to be using. And so far we have a sustain of 0. If I was to change this sustain to something above 0, you can see that it'll start rolling again at a slow level. If I zoom out here and take a look at the wheel, you can see it's slowly rolling. All right, so what we're going to do is we're going to, when we first trigger this, we're going to set the sustain level to something small, like 0.1 or something. And that way it'll spin fast, but when it slows down, it won't completely stop. It'll start rolling at this slower speed. And then when this modulus 1, sorry, I'm going back into spinner 1 here. All right. Here, this chop exec, when this modulus gets to 0, then it's going to stop. We're going to make that sustain go back to 0. Go away, text. I don't want to see you anymore. Okay? So, let's try this. All right, so instead of printing this, let's go ahead and comment that out. We're going to say x is equals, if x equals, or sorry, we need an if statement. If x equals 0, colon, new line, tab. Then we're going to say op trigger 1. What do we need to do to adjust that? All right, so the sustain, we got to find out what this is called. You can hit the plus, and it's called sustained. Right. So we're going to say, so if x equals 0, then op trigger 1 dot par parameters, remember, sustain equals 0. Okay. Let's see, is that it? Yep. All right, great. Let's try this now. It should actually, every time it's running, it should stop as soon as it gets to whole numbers, but it's not. Why? Let's take a look. Let me uncomment this print. Now let's open my text export. Now let's just stop this for a second. I'm not entirely sure why, but you can see it's actually doing a lot better now than it was before. But you can see here that it never gets to exactly 0. It's going from 0.97 and then it goes to 0.06. So if we're testing for 0, it doesn't happen. It just doesn't happen. And that's because you're working with floating point values that are incrementing in different ways, and they don't ever get to a whole number. But it's not the end of the world. We can actually fix that and make it work just fine, even though it doesn't ever actually go to 0. Instead of using a equals equals, we can say less than. X is less than 0.1, I think. 0.01. Do I get that low? Let's see. No, that won't work. It's got to be, because I went from 9.7 to 0.06, so that wouldn't work either. So let's just say 0.1. Okay, let's try that. So now, if I go ahead and resume, it stopped because this got to 0.05, and 0.05 is less than 1, and so the sustain stops. Okay, so now you're like, oh cool, I want to try that again, and it won't work because you'd have to, we manually adjusted this sustain in the trigger. So what we need to do is create another either trigger, either chop exec or something else that will adjust the trigger chop sustain parameter to this low value when you push the button. Okay, so we could add something to this chop exec. We could add another chop exec, but we haven't looked at this yet. And this timer actually has this here, this pink arrow, and these are callbacks, which actually work kind of like the chop execs. So you can see they have the same sort of thing, define, I mean they're different names, but it's essentially can run script the same way. You have on initialize, on ready, on start, on timer pulse, while timer active, on segment enter, on segment exit, cycle start, cycle end, cycle, and done, right? We actually want to add some code to on start. We're going to say when this starts, we're going to adjust that sustain parameter. So tab in, and we need to say we have something called chop exec enable, or is that in my file? Oh, that's later. Okay. There it is. Op trigger 1. Okay, so here on start, op trigger 1 dot par. What's it called? We need to figure out what that sustain is. There it is. That's right. It's dot par dot sustain. Dot par dot sustain equals 0.1. Okay, that way it'll roll as soon as you start. It won't roll that slow right away. It'll go ahead and do what it always did, but instead of stopping, it'll start rolling. And then when it gets to 0, then when the modulus gets to 0, it'll stop it. So let's try that out. So we just have this on spinner 1 right now. Okay. So there you go. You can see it stopped right at that 5. Let's try it again. See? Now it stops every time. Just this wheel stops every time with the number centered to where it needs to be. Let's dive back inside spinner 1. And you can see, actually, I don't have to. This should be. No, it didn't work. Because this should be a whole, something close to a whole number. Yeah, see, that didn't work. All right, so there's something going on. Okay, so I clipped out a major error on my part just to save y'all time. So yeah, we have this on start. We set the sustain level to 0.1. And then when the modulus of 1 gets to something close to 0, something less than 0.1, we set that sustain to 0, as you can see here, right? So that should work, but it doesn't. Let me show you that. So if this was working correctly, this LFO and this out should land on a number less than 1.1. And you can see that it probably won't unless we get incredibly lucky. It did that time. All right, let's try it one more time. See, it didn't that time. See, it's 5.3. So I was like, what is going on? And I figured it out. So what were we doing to make the wheel keep rolling after it was supposed to stop until it gets to a thing? We were adjusting the trigger sustain level, right? Take a look at this value. When I hit the button, that should switch to 0.1. Then when the modulus gets to 0 and under this chop exec, then that should switch back to 0. But you can see that it almost instantly goes from 0.1 back to 0 before the number has stopped rolling. Let's do that again. See how it landed on a number it shouldn't have landed on. Boom. Why? Well, it is analyzing every single value here that's coming through this LFO. So if you happen to be something close to a whole number, then as soon as that 0.8 reaches 6, this shuts off. And we don't want it to do that. We don't want it to actually activate until the timer elapses. And then also this trigger adds a 2-second, as you can see here, decay. So we need to wait, disable this thing, or this chop exec here. We could either disable it, or easier is just turn off this value change script when it starts, and then when this timer hits done, wait 2 seconds, and then turn this back on. And then it will run its code when it's supposed to run its code, and it should stop it the way we want. So let's see if we can accomplish that. So here under timer callbacks, this is where we're adding stuff. All right, so when we on trigger start, we are doing that sustain thing, but we want to also, before we do that, we want to turn off that chop exec. So op, what was it called? Chop exec 2. Chop execute 2. Yeah, chop exec 2. Sorry, I keep forgetting what it's called. It's kind of late here. Dot par. It's going to be a parameter, and now we need to figure out what it's called. So here in the chop exec, while a value change, if I click on this, it's called, oh, surprise, surprise, it's called value change. So dot par dot value change equals, what do you think it is? You guessed it, 0. That will shut that off. Then when the timer is done, on done, we need to add some code. So first we need to take this code, the chop exec par value change 0, copy, paste it down here. Make sure you put in your tabs. There we go. And that's going to be 1. But we need this to be delayed. Now there's a couple ways you can, there's more than one way you can delay things in Python, but be careful. If you just Google search on how to do a Python delay, the easiest, naive way will actually pause the entire system for whatever number of milliseconds that you specify, and everything will stop, and then continue on after that wait, which wouldn't help us any. We want the things to keep rolling and so forth. So we need to do a special type of command called delay, a run command, and a run command with a delay frames attribute. And this is a Python method that works in Touch Designer, and it's very handy. So the way it works, you have to create a, at least it's easiest, to create a, what am I calling it? A variable that contains this reference right here. So we're going to call this variable. We're going to call this delay underscore script equals, and then put this in quotes. All right, so we've defined this as delay script. Now we can run delay script and put a comma and then put in delay frames and make sure you put it that way. There it is. Okay, great. Yeah, so make sure you capitalize the F in frames. This is a variable that run understands, and you're going to put a number of frames that we want to delay it, which would be 120 to get that extra 2 seconds that the extra 2 seconds that the trigger adds, right? Because it has this 2-second delay, decay length. And so then this will, that chop exec will be turned off when you start, and then when it ends after 2 seconds or 120 frames, it'll be turned on, and then it will start doing what it's supposed to do. So let's try that out. And uh-oh, what happened? That value changed. It looked like I had an error there for a second. Let's take a peek. Oh boy. There we go. What's happening? Op exec par value change equals 1 line 1 name error. Chop exec 2 is not defined. Sounds like a typo. Let's take a look. Chop exec 2. Oh, do boop. Boop. There we go. That's what we messed up. Let's see, is it up here too? Oh no. Boop. Boop. There we go. That should fix it. Let's try it again. Now you can see the sustain level is set to 0.1. Then it got changed to 0 here at the end. And look where we landed. 6.05. That's pretty damn close to 6. So let's try that again. Yep, 8.05. That is really close to 8. All right, so that's working. And so now we just need to conform those changes to here. Let's just copy and paste these other spinners, right? I just want to make sure there's nothing in here that I need to copy. I haven't done that yet, right? No, okay, great. Yeah, so let's just copy spinner 1, get rid of spinner 2 and 3, copy and paste it, spinner 2 and spinner 3. Alright, they're rolling for some reason, but I think if we hit the button it should reset things. Boom. And check it out. 6.06, 4.06, 7.09. Those are all less than 0.1. And if we look at our slot machine, they're lined up perfectly. Let's hit the handle. All right. Except for they all look like they're all lining up. They're all stopping at exactly the same time. And I know why. And you know why? Because of the seeds. Because of the seeds in the random. So we have to go back in here and change something. I believe it's here. Yep. Random speed equals par the frame. So we need to make sure it has a different seed. So we're going to change that to +2. And we're going to say this random, and we're going to add a value to this. We'll say +3. And we'll do 4 and 5 on the other one. So then go out of that spinner 2. In here, spinner 3 now. Remember, if you ever get lost about where I am, take a look at the address up here. It tells you where I am. Okay, so here in chop exec, I want to say plus. Let's say what do we have? 2 and 3. Let's do +4 and +5. That way we get different seeds for every action in each spinner, and we shouldn't have identical random numbers, which is kind of defeats the purpose of random, right? So let's try it again. Boom. Looking good. You can see how they slow down and they land right where they're supposed to. And our wheels are going different speeds, you can tell. And they don't all stop at the same time. Okay, so looks like the last couple times we've had them stop in the order we want them to stop, but that has been random. See, this time it didn't. So that's the next thing we need to work on. Okay, so we just need to adjust the code in spinner 2 and 3 to make a consistent order of wheel stoppage. And basically we're going to add, let's take a look at that. So in spinner 2, where we calculate the time here, we have timer 1 par length equals this random amount times 5 plus 3. That gives you a range of from 0.3 to from 3 seconds to 8 seconds, some kind of random amount in between there. But what we really want to do is also add the amount of time that the previous stage waited. So that way this is always longer than that. So let's see if we can do that. Let's see. Do I have that code in my notes? Looks like I do. Okay, great. So par length equals to plus times 3. Okay. So what we're going to do is, instead of making it go from 3 to 8, we're just going to have a random time that adds between 0 and 3 seconds. And actually, let's make it it'll add between 1 and 3 seconds. So let's say times 3. Whoops. Plus 1. Okay, so that will actually, let's say times 2 plus 1. So that way it'll be at least 1, and then it will be up to 3 seconds longer than the previous. And now we have to add the previous. So we say plus, and then this is where we have to point to something that's in a totally different container. And so we're going to use an absolute path instead of our relative path that we've been using in the past. So we're gonna point to the length of the timer 1 that's sitting in spinner 1. So op. Actually, let's do it this way. Let's use a variable, and let's call it stage 1. So you're going to have this random amount times 2 plus 1 plus whatever the amount in stage 1. Now we need to define stage 1. We can do it here above these definitions. We can say, let's see, we're going to say stage 1 equals op. And this is where it gets hard, because we have, like I said, we have to use an absolute reference to point to that other timer parameter. So we're going to say open quote, single quote, / project 1. See this here? This is project 1 spinner 2. We're going to say project 1 / spinner 1. / and then the operator, which is called timer 1. Okay, single quote, close parentheses, and then dot par, dot length, length. Yeah. So that should now add this, the amount that's sitting in this length, and I can show you where that is. If I go out of spinner 2, come on, there we go, and I go into spinner 1, we're talking about, on this timer, this length here. So it's going to add 5 seconds and then some random amount between 1 and 3 seconds after that. Okay, so let's try that out. Actually, let's just go ahead and add the change to spinner 3. So let's go back. I'm back in spinner 2 now, right? See, I'm in spinner 2. And whoops, I don't want to add an object. I'm going to grab this code so I don't have to do it again. Here, I'll just do all of this. So grab all of this code, copy, and now go out and go into spinner 3. This is in the chop exec. There it is. Let's just paste it up here, and I'll just clip out what we don't need. Right? So we need that. Oh, I see. Let's just clip this out. Boom. Okay? So now that's back to the way it should be, except for we just need to conform this. Instead of saying timer spinner 1, we want to point to the amount of time that we waited in spinner 2. And so now op timer 1 par length equals some random amount of time between 1 and 3 seconds plus stage, let's call this 2. Stage 2. Make sure you change up here to stage 2, and then down here you change that to stage 2. Alright, that should do it. Let's give it a shot. So, hitting the button. They roll. Rolling like thunder. Stops at. But why? Let's take a look. I feel like it's not quite working right. That's right, 1. No, that's wrong. All right, so something's up with that wheel 3. Currently, there's a little bit of an issue where the wheels don't always stop in the correct order, 1, 2, and 3. And the reason is that when you click this button, it runs all 3 of the codes in all 3 of these spinner containers at the same time, and it runs them within 1 frame because they're not that complicated. Okay, so when within 1 frame, spinner 2 is trying to pull the no, maybe it's in this code, the chop exec. Yeah. Spinner 2 is trying to pull the time that we called stage 1 here from this operator path, right? We had to use, this was in the video last week. So we use an absolute path to point to the length parameter in timer 1 in the spinner 1 object, and we're calling that stage 1 time. Right, and then in spinner 3 we have a similar variable called stage 2, and it points to spinner 2 timer 1 par length. Right, and so when we're adding stage 1 or stage 2 to that, it's pulling that value, but that value hasn't been updated yet for the time that you just pushed the button. So it's actually pulling the value from the last time you pushed the button, which is what is throwing off. Which sometimes it works fine if it happened to be that the length was such that the wheels would stop the last time you pushed it, the wheels would stop in the correct order this time you push it, but obviously that's not going to happen every single time. So what we need to do is simply create a delay of only a 1 frame delay, which you won't really notice, before spinner 2 executes, and before an additional frame delay before spinner 3 executes. That way each one can get their variable populated with the current timer par length, right? So it's a really simple fix. So here on going in from the button into spinner 2, we're going to insert an operator, and it's going to be a delay chop. Okay, and by default it wants to have a 1 second delay, which is way longer than we need. So we want to change this to a frame. So go down over here to this drop down list and change that to frames. Then you'll notice that, well, you might not notice, and I didn't the first time, that it updates that to how many frames are in a second, and it runs this all the way up to 60. So we need to take this back down to 1 frame. That's all we need, is a single frame delay. Okay? Then, what do you think I would put here? Going into spinner 3. Same thing, right? Delay. And change this from 1 second to frames, and from 60 frames to 1 frame. Okay? Why would this not work necessarily? Anyone? Because spinner 2 and spinner 3 will still happen at the same time. How could I change that? I could do delay 2 frames, or maybe a little more elegantly is I could take this button and instead drive it from the output of the previous delay. Then I know that that will always happen after this one, right? There is a conceivable notion that something glitched on your computer causing it to slow down, and delay 1 here hadn't quite executed by 2 milliseconds, and then delay 2 executes, and that conceivably could mess things up. And if you do it this way, this cannot execute until delay 1 executes, right? So that's a little bit more elegant. But you're right, yeah, that would probably work. All right, so that should fix the stoppage, wheel order stoppage. So let's try that out. I'm going to hit my little open, and we have random speeds, and they should stop 1, 2, and 3. 1, 2, and 3. And it will work every time that way. One, 2, and 3. Right? Okay, great.